Hello and welcome to Advent calendar number 11, which is on Redshift from the Expanding Universe. Question 7 is looking at the spectra or spectrum, the visible spectrum from the sun, and you have a visible spectrum with lots of black lines on it, dark lines, and the first part of the question asks you to explain how these dark lines in the spectrum of sunlight are produced, and it's due to absorption. So that's what you're looking to try and explain this in terms of. So for, let's call this 11A, the dark lines are caused by absorption. So gases in the atmosphere of the sun absorb particular frequencies leaving dark lines. Now you could go into more detail about that, it's only worth 1 mark though. You could say that it depends on the elements and the structure of the energy levels, but we're not going to go into that in too much detail at this stage. You don't need to, and you wouldn't be expected to know the energy level setup for different elements, so don't worry too much about that. Part B, one of the lines is due to hydrogen. The position of this hydrogen line in the visible spectrum is shown for a distant galaxy. Explain why the position of the line is different in each of the spectra. So you've got a distant galaxy, a nearby galaxy, and the sun, and if you notice, the further away the galaxy is, from the observer, the more redshifted the spectra or spectrum is, due to further galaxies having greater recessional velocities. That's Hubble's law. Okay, it's just a 1 marker, so you just have to talk about redshift and further galaxies travelling at greater velocities away from the observer. Part 2 asks us to show that the redshift of the distant galaxy is 0.098. So we have wavelengths from the diagram. So the redshift is the change in wavelength over the rest wavelength. So if we look at the distant galaxy, we need to read off the wavelength, which is 450 nanometers. And we need to compare that to the rest wavelength, which would be the sun, which is the close object to us. So the sun's wavelength would be 410 nanometers. So we would do 450 minus 410 divided by 410. And that would give us the redshift. Now you don't need to have the nanometers because all the units are the same. So you can just work in the values that are given, and if you do that calculation you end up with the value that they are expecting, 0.098. There are no units for redshift, so you don't need to have any units. It's a show question, so a show question must have the equation from the relationship sheet, must have a correct substitution, and it must have the answer that they're looking for the 2 marks. Okay, so we're now asked for the approximate distance to the galaxy. So this is a multiple step problem. So we have the redshift, and the redshift is equal to the ratio of velocity to the speed of light. So we can work out the velocity of the light. Velocity is equal to the redshift multiplied by c, which is 0.098 multiplied by 3 times 10 to the 8, or 2.94 times 10 to the 7, sorry, meters per second. And then if we use Hubble's law, we can get the approximate distance to the galaxy. So Hubble's law it compares recession velocity to the distance to the galaxy, and we can rearrange that so we have distance is equal to the velocity divided by Hubble's law, which is equal to 2.94 times 10 to the 7 divided by 10 to the negative 18. It gives a distance of 1.28 times 10 to the 25 meters. And we've worked in 3 sig figs because 3 sig figs were the values given to us in the question. Actually, if you look at the show question, the answer is given to 2 sig figs, so the correct answer would be to 2 sig figs, but you're allowed +2 or -1 significant figures. So we are happy with that answer. So part C asks us to explain why the spectra in the diagram in part B support the theory of the expanding universe. And they show that more distant galaxies are moving away at greater velocities. Okay, and that completes that question, number 11 in the Advent Calendar.